collision detection, game development. And in the previous video, we created the brick field. And as you can see right now, we're playing these games, and we created some bricks over here on the top, but they're not doing pretty much nothing at this point. So we're gonna still working on it right now. Okay, so this is the 7th step out of 10 of the game Canvas tutorial. You can find the source code. I should look after completing this lesson, so you can check it out in the GitHub repository. You have it here, the link. We have the bricks appearing on the screen already, so as you can see it here in this is the bricks, but they're not doing anything yet. Okay, so but the game still isn't that interesting as the ball goes through them. We need to think about adding collision detection so it can bounce off the bricks and break them. It's our decision how to implement this, of course, but it can be tough to calculate whether the ball is touching the rectangle or not, because there are no helper functions in Canvas for this. For the sake of this tutorial, we will do it in the easiest way possible. We will check if the center of the ball is colliding with any of the given bricks. This won't give a perfect result every time, and there are much more sophisticated ways to do the collision detection, but this will work fine for teaching you the basic concepts. Okay, so a collision detection function. To kick this all off, we want to create a collision detection function that will loop through all the bricks and compare every single brick's position with the ball's coordinates as each frame is drawn. For better readability of the code, we will define the b variable for storing the brick object in every loop of the collision detection. Okay, so we have pretty much this function, and let me see. Okay, so we have this function, and we can pretty much go into our main.js, and we can pretty much go all the way. Let me see, key handler. We can go, we have to draw bricks. Okay, so first of all, we have this function named collision detection. Okay, so we are using a for loop, and inside of the for loop, inside of the parentheses of the for loop, we have the initialization, we have the condition, and we have the afterthought. Okay, then inside of this for loop, inside of the statement, we have another for loop as a statement. So we have that, and then we have some theory here. So let me see, let's write down, let's write that down in code. Let me see. Add the above block code below your key app handler function. Okay, so we're gonna go into the key app. So key app. Okay, so we start here. Okay, it's gonna be here. So add the above block to your code below the key app handler function. Okay, what we are gonna do is we're gonna start working with this function. Yet we're gonna modify it, but let's have it. So we're gonna have this function, and we are gonna name it collision detection. So it's gonna be collision detection, like this. Okay, so it's gonna be collision detection. Okay, so it's gonna be a function. We're gonna open curly braces, and okay, so function collision detection. Okay, so we're gonna have a for loop. Okay, and we're gonna have some curly braces here, and here in the parentheses of the for loop, we're gonna have the 3 expressions. So we're gonna have the initialization, so we're gonna let this variable name c, and we're gonna initialize it to 0. Then we're gonna have a condition. As long as c is less than the brick is gonna be column count. Let me check it out. Brick column count. Okay, as long as the variable c is less than the brick column count, we're gonna separate it with semicolon, and we are gonna increment c by 1. So we're gonna type in c++. Okay, so now here we're gonna have a statement inside of the curly braces of the for loop, and inside of this statement we are gonna have a second for loop. Okay, so again with parentheses and curly braces, And here we're going to do the same. We're going to initialize a variable and we're going to initialize it to 0. We're going to separate it by semicolon. We're going to have a condition as long as r is less than the brick, as long as brick row count. So it's going to be brick or row count. Okay, so as long as r is less than the brick row count, we're going to increment r by 1 like this. And as a final statement of the second for loop, we're going to have this constant declaration named b, and we are going to set it to the bricks. So we're going to set it to the bricks, and we're going to use arrays. So we're going to pass in c. We're going to open another array that is we're gonna pass in r. So let me see, that's fine. Okay, that's right. Semicolon at the end, and again nothing is gonna change. So this is pretty much the body that, or the model that we are gonna follow. If the center of the ball is inside the coordinates of one of our bricks, we will change the direction of the ball. For the center of the ball to be inside the brick, all 4 of the following statements need to be true. The x position of the ball is greater than x position of the brick. Okay, this is the first. The x position of the ball is less than the x position of the brick plus its width. The y position of the ball is greater than the y position of the brick. And finally, the y position of the ball is less than the y position of the brick plus its height. Let's write it down in code. So again, so now we're gonna pretty much update this collision detection function that we just created and that we have typed below the function keyAppHandler. Okay, so let me see, the 4 statement is fine, the green, okay, that's fine. Then we have the brick row count, that's fine as well. Okay, so yeah, that's fine, up to here is fine. Now what we are gonna do is pretty much we are gonna add an if statement declaration inside of the curly braces of the second for loop. Okay, so we're gonna go after the semicolon of the constant declaration b, and we're gonna have this if statement declaration, and here we're gonna have pretty much these 4 conditions, and we're gonna write it as follows. So we have that x, okay, if x. Okay, so first of all we have the if statement declaration, and here we're gonna have the parentheses, but I mean the curly braces, but in the parentheses we have that if x is greater than b dot x. So pretty much what they're saying is going to be the first one. The x position of the ball is greater than the x position of the brick. So we have that if x is greater than b dot x, and so double ampersand, and okay, so n x is less than the b dot x. So if x is less than b dot x, so it's gonna be if the, okay, here the second one is gonna be the x position of the ball is less, the x position of the ball is less than the x position of the brick plus its width. So we have this piece of code that up to this point. Let me see. Okay, so what we are gonna add now is gonna be pretty much this one. We're gonna add the brick width. So as you can see here, is less than the x position of the brick plus its width, so we need to add the width. So we're gonna pretty much just have plus brick, and it's gonna be width, it's gonna be this one. Okay, so we have this, we have these 2 statements already, so we need 2 more statements. Okay, so we have that, we have this statement, we have this statement. Now we're gonna separate, or we're gonna use the logical AND operator, double ampersand. So we're gonna go for the third one. We're gonna have that ny is greater than the b dot y, and y is greater than b dot y. So pretty much we're saying that, let me see, I'm just gonna duplicate it, and what we are saying is that the y position of the ball is greater than the y position of the brick. So the y position of the ball is greater than the y position of the brick, so y is greater than b dot y. Okay, and so that will ampersand, and so we're gonna have the final condition. The y position of the ball is less, so let's type it in. So the y position of the ball is less than the y position of the brick. So the y position of the brick would be b dot y plus the height plus its height. So pretty much it's gonna be like this in brick height. Okay, so everything is fine up to this point. Brick height. Okay, save it. Let me see what else do we have here. So if this condition is true, then we're gonna execute something in the curly braces, and in the curly braces, if this comes to be true, then the variable dy is gonna be set to the negative dy, semicolon at the end. Let me see. Okay, that's fine. And then we're gonna have the 4 curly braces. So 1 2 3 4 curly braces, so that's fine. And again, nothing is gonna change yet, so we have this up to this point, and let's keep moving. Okay, so add the above block to your code below the key up handler function. So we already did that. Now making the bricks disappear after they are hit. The above code will work as desired and the ball changes its direction. The problem is that the bricks are staying where they are. We have to figure out a way to get rid of the ones we already hit with the ball. We can do that by adding an extra parameter to indicate whether we want to paint each brick on each screen or not. In the part of the code where we initialize the bricks, let's add a status property to each brick object. Update the following part of the code as indicated by the highlighted line. Okay, so update the following part of the code, and let me see. Okay, so we are gonna have let me check it out. Making the pros disappear. So let's add the status property to the each brick. Update the following part of the code as indicated by the highlight. So we have the constant bricks. Let me see. And I'm gonna be bricks. So I am in line 27. So I have this constant declaration named bricks, and it's being set to this empty array. Okay, so we're gonna update it. So let me see, everything is fine up to this point. We have this for loop. Let me see, we're initialize it to 0 as long as c is less than the brick column count, and we're gonna increment c by 1. Then we're gonna have the bricks. We're gonna set it to an empty set of brackets or an empty array, and then we're gonna have this for loop, and we're gonna have the let r is initialized to 0, brick row count. Okay, we're gonna increment r, and the statement of the second for loop, we're gonna have the bricks cr, and then we're gonna set it to this object. And in this case, we have this key value pair. The key is going to be x and the value 0, key is going to be y and the value 0, but since we are modifying it, so we are adding a status. So this is the only update that we are doing. We are adding a second parameter to this object, and we are separated with a comma, and we're going to have a status, and we're going to set it to 1. So let me double check. Status set or status. Okay, and we're going to set it to 1. Okay, so that's all the update that we need to do. Next, we will check the value of each brick's status property and the draw bricks function before drawing it. Okay, so if status is 1, then draw it, but if it's 0, then it was hit by the ball and we don't want it on the screen anymore. Update your draw bricks functions as follows. So we're gonna deal with the draw bricks function now. And again, if right now we don't have much code, so we only have 131 lines of code, but I always like just Control F and then just we're gonna name it draw. What is the name? Draw bricks. So we're gonna just draw bricks, and this is the function. So it's in line 51 in my case. So okay, so I can just maybe close this one. We have the function draw bricks, so we're gonna update it. And one thing you can do is just delete it, this whole function, and just copy and paste it, this one. But let's just go line by line. So we have the lead, okay, so that's fine. Row count. Oh, we have the draw bricks. So we for lead, C is assigned to 0 as long as C is less than the brick column count. Okay, brick column count, that's fine. We're incrementing C by 1. Okay, so the second, okay, so we have R set to 0, initialized to 0 as long as brick row. We're incrementing R by 1. Okay, so let me see what else do we have here. Okay, so yeah, what I'm gonna do is I'm just gonna pretty much copy this whole thing, and then we are gonna descend here, so just I don't make any mistakes. So I'm gonna save it for now. Okay, so pretty much we just updated this function named draw bricks. So we have this for loop. This for loop inside we have these 3 expressions. So we have the initialization. C is initialized to 0. Okay, so C is being initialized to 0. As long as C is less than the brick column count, we're gonna increment C by 1. Okay, inside of the curly braces of the first for loop, we're gonna have a statement, and as a part of the statement we're gonna have a second for loop, and we're gonna have, again, we're gonna initialize the variable R to 0. As long as R is less than the brick row count, we're gonna increment R by 1. And inside of the second for loop, we're gonna open curly braces and we're gonna have an if statement declaration. Okay, so inside of this if statement declaration, we are gonna have this condition. So if the bricks, and we open brackets C, we open brackets R, that status is equal to 1, if that is true, then we're gonna have this constant declaration named brick X, and we're gonna set it to this equation that is gonna be the variable C multiply by the sum of the brick width and the brick padding. Okay, so we multiplied the result with C, and then we added to the brick offset left. So let's see how it's looking up to this point. Okay, so it has changed the color, but if you go in hexadecimal and you can play around, maybe you want to grab this color maybe. So you go here and just paste it, and we will have pretty much these colors here. So we have modified the color. Okay, so let's keep moving. Inside of the if statement declaration, we have a second variable. This constant is named brick Y, and we are setting it to the multiplication of the variable R and the sum of the brick height and the brick padding. So this whole result, we are going to add the brick offset top. Okay, so we have those two. Now we're going to use the bricks, and then open brackets C, open brackets R, and then that X, so that is the position X, and we're going to set it to the brick X. We're going to do the same thing with the position Y, and we're going to set it to brick Y, and then we're going to open the CTX that begin path, and we're going to end it with the CTX close path. and in between we're gonna have the CTX, that's rectangle, brick X, brick Y, and brick width and brick height as parameters. We have the CTX fill style, setting it to the scalar, and then we call in the CTX fill function, and finally just the CTX close path. So we have that, and this is the final result up to this point. Okay, so again, nothing has changed yet, so we have that. So let's keep moving. Tracking and updated the status and the collision detection function. So pretty much the important thing that we just pretty much updated was this if statement. So we have this statement here. As long as this statement is true, as long as the bricks C, array C, array R, that status is equal to 1, as long as that is equal to 1, we're gonna call all of this. So okay, tracking and updated the status and the collision detection function. Now we need to invoke the brick status property and the collision detection function. So let me, okay, so that is in the final. So this is the collision detection. Okay, so if the brick is active, its status is 1. We will check whether the collision happens. If a collision does occur, we will set the status of the given brick to 0, so it won't be painted on the screen. Update your collision detection function as indicated below. So let me see. Again, you can just copy, you can delete it and just copy and paste it if you feel more comfortable, but let's check it out right now. There's not much code here. So we have that if C is set to 0, as long as C is less than the brick column count, we increment the C by 1. Okay, we have R set to 0 or initialized to 0, we are incrementing R by 1. Then we have that B is set to CR. Okay, and then we have this statement declaration here. Okay, so as long as, let me see, so we have an if statement declaration, is gonna be this one, that's fine, but we are gonna have this if statement declaration is gonna be inside of the second of a first if statement declaration. Okay, so the first statement declaration is gonna be the brick that status is equal to 1. If the brick status is equal to 1, then we're gonna call a second if statement. Okay, so after that we are gonna have the dy is set to negative dy, and also the brick status we're gonna set it to 0. Okay, so what we can do right now is pretty much, after the curly braces of this bricks bracket C bracket R, we can just create a second if statement, curly braces. Inside of the curly braces here, we could just pretty much grab this whole curly braces and paste it here. And okay, so here we'll have our bricks that status, and we're gonna set it to what, I mean, if the bricks that status is equal to 1, then we're gonna have this, we're gonna execute this code, and also we're gonna have the bricks that status, and we're gonna set it to 0. Okay, so we have that. Let me see. Okay, so we have that up to this point. Let me see. And then we're gonna have 5 curly braces, and pretty much you can do that, or just pretty much, let me see, yeah, that's fine, or you can just pretty much delete this whole thing and just copy this code here if you feel more comfortable. Pretty much the same thing, but again, it's gonna be, we're gonna have this if statement declaration, and inside of the curly braces of the if statement declaration, we are gonna have a second if statement declaration that we already we already had. So that's pretty much it. And inside of that, we just had the, if that is, if the statement was true, we are setting it dy set to negative dy, but now we're gonna set also that I break that status, we're setting it to 0. So we have that up to this point. Let me see. Yeah, nothing is changing yet, so we need to call it. Okay, so now activating our collision detection. The last thing to do is to add a call to the collision detection function to our main draw function. So, and again, since we are having in the last line, we have this constant declaration interval, we are setting it to the set interval, and we are calling the draw function. And again, the draw function is way over here. Yeah, this is the draw function, so let's keep that in mind. Okay, so add the following line to the draw function just below the draw paddle call. So what is the draw paddle call? And what we are gonna add here is just gonna be collision detection. So it's gonna be collision detection, and since we are calling it, we have to use parentheses, semicolon at the end. And here we have, so compare your code. So this is what we have right now. Oops, let's play it again. So okay, so we are playing it now. Is the deleting. Let me check it out again. Okay, I'm playing the game. Okay, so now it's pretty much deleting all those bricks. So now we are getting somewhere. It's getting kind of cool, this game. Okay, so okay, let me see if I can. Oops, I lost. So but yeah, I mean, you can play around this game here, but right now we need to add a score because we're just playing, but we don't know if we're, well, we are not keeping a score yet. So we are gonna do that in the following video. So what we have now is compare your code. The collision detection of the ball is now checked on every frame with every brick. We can now destroy bricks, so that's cool. And again, you can check out your code, your piece of code. You have the JavaScript here, and also you can as you can see, you can check it out in this same website. So, or you can go into the game dev canvas. You have this GitHub repository where you can pretty much compare your code. So try changing the color of the ball when it hits the brick. So we can also, I don't know, maybe change it to this color here. You can play around with the hexadecimal colors. And yeah, this is pretty much all that we have for the collision detection.